Hey, hi. Well, that was painful. Maybe for me more than you. At least I'm getting quicker at deleting the video. It's the only way I can figure it out how to start again. Thank you for coming back. You like the thumbnail. Thank you. I did it for you guys. It was my look of frustration, right? Thank you, Oscar. Okay, we can finish the problem. Hallelujah. It's not hard, but I wanted to finish it with you today. So we'll wait till I get closer to 15 and then we can do this. Okay, back to the important stuff, not the guy with his eyes on the ceiling. Okay, so while we're waiting for everybody to catch up, good. Oh, you guys are quick. I love it. So we have only HI. So therefore, how much do we have initially of H2 and I2? No, it's not a trick question. We have only HI originally. So how much H2 and I2 do we have? Ah, Louisa. Okay. Okay, Louisa, you want to get some notes from somebody. I won't be able to send out the video because it's gone. And hi, Chelsea. Okay, so how much H2 and I2 are there? You got it. Yes. Yes. Good. 0. So if it says I only got one chemical, here's what you do. So I have none of the others, okay? Initially, I have no H2 or I2. Okay, the change is something we got to do some thinking about. So let's go ahead and go down to equilibrium as well. So they tell us we got something here. Go back to your info. Sometimes you got to read these problems 2 or 3 or 4 times, okay? Okay, at equilibrium, I've got the H2 is 0.10 atmosphere. Okay, you ready? So I've got H2 equilibrium 0.100 atmospheres. Now you do a little detective work. You ready? Check this out. If I had 0 and I got 0.1, how much did I have to add here to get 0.1? I hope your answer is 0.1. Okay, now back to our equation. Check this out. I didn't have any of this. Now I got some of it. So probably if I have some H2, I also have some what? Good, a lot of you figured that out, 0.1. If I got H2 forming, I probably am also forming some thank you, Lola, I2. So I'm going to have, and now look at this, even better. You ready? Here's the mental math. Well, for every one of these, I form one of those. So if I formed 0.1 of these, I probably also formed how much I2? 0.10. Is it that easy? Yes. So if it's 1 to 1, then down here, if I know this one, I know that one also. Okay, if I added more on this side, then probably on the other side, I've got to take away something. Okay. Oh, did I do it the same way as you guys did? Yeah. So how much, thank you. Let me ask you now and wait for an answer. How much do you suppose, my markers, how much do you suppose I got to take away from this? Hint, look at the reaction. So what will I take away from the 1 atmosphere? How many atmospheres will I subtract? Look at above. So if I gain 0.1 and 0.1, then how much am I going to take away from up here? And Sophie's got it. Let's see if somebody else catches up to her. She used the coefficient. Oh, For every one of these, I took away 2 of those. So she's taken away 0.20 atmospheres. So she's right. Now let's do the math, okay? Well, then at equilibrium, 1 minus 0.2, that's easy, 0.80 atmospheres. We got this one given to us, and let's do this one. Well, that's just the same thing as H2. For I2, it's 0.10 atmospheres. So now let's answer our questions. Remember, a good AP student has to also answer the questions. Okay, so A, find the PI2 at equilibrium. PI2, bang, 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 okay? So it's 0.10 atmospheres. And what does B want? It wants the HI at equilibrium. Oh, 0.80 atmospheres. C wants the K value. We need a little board space for that. Okay, thank you, Mina. I'll try and save this, but I got to erase a little bit. But I'll save this, Amina, to the stream so you can see what I just erased. Well, you have the problem probably. Okay, so let's get the K. So essentially we're on part C. So for part C, we're going to say K, and let's do the expression first. So it's what? It's the partial pressure of H2, and we're doing products over reactants, times, remember this becomes a times, even though it's plus in the problem, times the pressure of I2 over, see if you can remember how to do this, although I don't really want to take the time because we're running out of time, over the pressure of HI, I, to the bang, bang, second power. But now you can put in your numbers and actually get an example, okay? So what is K? K is, and this is the work you'd want to show, first the expression, now the numbers substituted in, just like I've always done with you. So equation, numbers substituted in. So I got 0.1 times 0.1, so we can definitely say 0.1 atmospheres squared. And on the bottom, it's what? 0.80 atmospheres squared. So I'm going to let you do that math and find out what K is, and let's agree on it. What is that K? Go ahead and punch that out, and let's find out. Okay, so let's find out. Can you cancel out the square? Anne Sophie says, no. Simply put, no. Got to square the top one, square the bottom one for this one. Be nice, but I can't. Good, we're getting the same thing, 0.156. Given that number, what is favored in this reaction, reactants or products? Given that number, what's favored, reactants or products? Ooh, I got a discrepancy. Okay, is it 0.156 or is it 0.0156? The reactants are favored either way. Okay, I'm missing a zero. Is that correct? Can everybody punch it again? It'd be what? 0.01 divided by 0.18. Oh boy, 0.01 divided by 0.18. It's probably, I don't know. Are you sure it's 0.0? Is that right? Yeah, okay, Amina got the same thing? Okay, all right. Thank you, thank you. Don't have a calculator handy, so I appreciate your good work. Okay, good. Now, I got to tell you something about K values. These equilibrium constants, Ks, here it looks like the atmospheres cancel. It doesn't matter. K never has a label. Ks have no label, ever. It's just a number compared to 1. So even if it looks like it doesn't cancel out, you don't have a label anyway. It's just always some number. Greater than 1, less than 1. Okay? Okay. All right, good. Let's go on and talk about another little doohickey. And I'm going to pause and see if you got any questions. Okay. All right. Okay. All right. So I think you got that. So I think it was 0.0156. Thank you for participating. Here we go. It's not easy. You guys do a good job there at home. I appreciate it as a teacher. Let's talk about something that's really related to this. Let's talk about the reaction quotient. Q. What is it? Well, it's the same as K. But not at equilibrium. I like to tell everybody that it is K's little brother. When I grow up, I want to be just like K. What does that mean? It means if I'm a reaction, what do I have to do to make my Q become K? Sometimes I got to make more product. Sometimes I got to make more reactants. So the use of Q is predicting which way the reaction will run. We're going to look at that again in a sec. Let me read some comments, see if I'm missing something. Oh, you can't cancel out the squares. Yeah, right. Because if I cancel out the squares, the only way I can do that, Sophie, is I take the square root of the other side. Then it's not K anymore. It's the square root of K. So I can't do that because it changes the K value on the other side. Okay. There are times, Sophie, where we are going to take the square root of both sides, but we'll see when that is and why. Okay. Q can tell you which direction the reaction will proceed to get to K. No, we're not. We're going for a couple more minutes, Sophie. So let's talk a little philosophy for the last couple minutes, okay? We'll do an example next time. It's sort of like this. Let's say I'm a cake baker and I'm just not that quick. So I can make 2 cakes in an hour, okay? So, but my friend, she's great, man. She can make like 4 cakes in an hour. So what I have to do to achieve that other goal is I've got to make more product. I've got to make more cakes to get my number up to 4 per hour. Now, let's say it's a different product. Okay, I'm a cake baker and I make about 1 mistake an hour, which is kind of a lot. And my other cake baker, she's really good. She makes zero point zero 0.01 mistakes per hour. So what I got to do is I got to make my number of steaks get less. So I want that to be less to get to as good a percentage of mistakes as she has. So my philosophy is sometimes I need to have more products to make my Q become a bigger number, like K. And sometimes, depending on the K, I need to have the Q become less of a number so to get closer to K. So maybe I got to make more reactants instead. So I can go back and forth, and we're going to play that game next Wednesday, along with hopefully a demo if I can get it going at school. Thanks everybody for joining me. I'll save this little video for those that missed this part. The other one is gone, but luckily most of you are here today. Okay? Thank you for joining me. We'll see you on Wednesday. Stay healthy.